We start by defining dark data. Gartner defines dark data as the set of information assets organizations collect, process, and store during regular business activities, but generally fail to use for other purposes. Data could have been left behind from completed projects, from modified processes, inactive databases, or even organization restructuring. And organizations often retain these assets for compliance purposes only, or maybe use them once and then file and forget, which incurs more expenses and risk than value. So dark data is hidden information that takes huge amount of space in data centers, generate greenhouse gas emissions, and in some cases leads to incorrect conclusions, poor decisions, and of course, negative actions and consequences. Now, when we talk about data and its effect or the power of data in digital transformation, first we define what digital transformation is. In simple terms, digital transformation is maintaining competitive edge and better business through the continuous management of a customer experience. Or in more professional terms, we define digital transformation as a journey of continuous improvement of business processes and organizational culture to transform the customer experience while using technology as an enabler. And in doing so, digital transformation relies heavily on data and on analytics to continuously challenge the status quo, to identify new opportunities, and transform business process workflows and align with evolving customer needs and interests. So successful digital transformation depends on how an organization restructures itself, its processes, and its human capital to unlock value from data. So data is always significant in digital transformation. Before we talk about dark data and the origins of dark data, we need to talk first about the different data sources, the different data formats and characteristics. So first, the data can originate from the most popular sources of data could be from survey data that are gathered from a group of people about certain topic of research, maybe transaction data gathered at the point of sale involving selling and or buying. It could be sensor data gathered by device from physical environment, location data, which includes information about geographic positions of objects like devices, cities, buildings, roads, and so on. It could be also originating from social media gathered from digital posts across social media platforms. And of course, it could be from synthetic origins, which mainly are computer-generated information through machine learning algorithms. The data could be in three different formats, either structured, unstructured, or semi-structured. If it's structured, it can be represented in rows and columns as tabular data. They have predefined formats and can be easily collected, accessed, organized, and processed. Like survey data, for example, transaction data, sensor data, location data, they all have structured formats. An unstructured format doesn't have any predefined structure. And it could be represented by text, image, audio, video, and this is almost 80% of business data. We can also classify a format that is semi-structured, which can have some structure to it, but may not have that consistently implemented across all data. And we can find examples for this that could be XML, JSON, or HTML files. When data becomes large and complex, beyond the ability of traditional databases to access and process it with low latency, then we refer to this kind of data as big data. And we use AI and analytics to extract insights from big data. Big data is characterized by volume, variety, and velocity. And by volume, we mean the amount of data that is needed for storage and access, given the capacity constraints of the current data infrastructure that we have. The data variety include the different formats of data and how we can consolidate them together into a single system that can be accessed, processed, and utilized. And the third characteristic is the data velocity, which refers to the speed at which data is generated, distributed, collected, and processed, as well as the infrastructure needed to handle the storage, the real-time processing, and analysis of data that is continuously being generated. Now that we talked about the data sources, formats, and characteristics, we may turn to the different types of dark data. There are so many types of dark data, but we have selected the most popular types to talk about in this webinar and in the paper. First, we talk about the protected data. And this is non-hidden data, but cannot be used due to various reasons, like, for example, government regulations, organization policies, contractual commitments, and others. Examples could be customer information in banks, could be patient information in hospitals, where the records cannot be used for fear of misuse, bias, or even GDPR. So valuable data gets recorded and is out in the dark for the right reasons. However, it is useless for any decision-making, except for limited use by government and maybe regulated research. Obviously, the resource consumption to collect, store, and secure from misuse is a drain and contributes a lot to the computing carbon emissions. The next type of dark data we are going to talk about is the expired data, which was once relevant, but as time passes, it becomes idle and becomes like a depreciating asset. The longer they remain, the less value they have. Examples could be weather data, could be stock market data, and other examples. So expired data could evolve from data that was once correct once upon a time, with no relevant updates made for some time, or updates that are not reflected across all repositories or replicas of the application or solution. It does not represent the truth. It only adds carbon emissions and impairs trust and reliability of the solutions that are based on this kind of data. Then we go to unlabeled data, where we find that a lot of organizations, they possess massive amounts of data that is not properly labeled or lack identifiable schema. Without metadata on the lineage, on the ownership, the revision history, the semantics of the data elements, data may look just like a collection of numbers in alphabets, which is a waste of space, of course, and of processing power. When we come to the incomplete data, we are referring to a data that could have missing values for specific columns in data records, or for a particular date, or country, or region, or even a branch office, or for specific employees in an HR database, products in the product profiles database. So it's a headache in analysis, and inside generation, this could make a total record useless. Then we go to the incorrect data, which simply results from incorrect numbers, typos, transposed letters, cut and paste errors, etc. The most challenging part here in the incorrect data is the detecting of the incorrectness, which often gets overlooked. We can also find improperly represented or formatted data, which is in unrecognizable formats. This is another big issue in wasted resources of computation and of storage, sometimes rendering it useless. Applications may be expecting data in a particular schema, and some of the data sources or providers may not adhere to this schema. Examples could be date formats, abbreviations, audio or video formats. Even simple labeling variations in JSON files can cause some data analysis issues. So improper formatting can cause data analysis issues in addition to the storage and processing power that is wasted as well, adding more to the carbon emissions as well. When we come to the biased data, it can manifest as incomplete data due to either neglect or intent, because biased data may lead to incorrect results. It can have adverse impact on society at large and may even result in a threat to life. An example could be having, for example, a population sample that is not properly randomized. This means the sample isn't representative. It doesn't truly reflect the analyzed population. The main challenge here is the complex process of detecting the bias. If it is intentionally introduced, and once data has become biased, it is largely impractical to make it useful anymore. And then the last type I'm going to cover here is the data that is yet to be discovered. And it includes two subcategories in the paper. The first category represents the data that is out there but never collected or utilized. And it represents a missed opportunity to make good use of the data that is present but ignored, to be recorded or used to improve business operations. The second category is where data values or records are misplaced and are never identified as valuable. So it represents an unintentional mistake or ignorance of the utility of data that is already there. It causes, of course, wasted resources in collecting data, which never leads to any meaningful use of that data. So this happens either because of the lack of awareness on how to use this data that has already been collected, or because of the legal or other restrictions on their usage, like HR documents, personal finances, etc. And here I end by a simple example showing the impact of data that is yet to be discovered. It can be illustrated in the 1936 US presidential elections, where there's a popular magazine, Literally Digest, had previously successfully predicted winners of the elections. And in 1936, it predicted that the Republican candidate Landon would win. However, Roosevelt, the Democratic candidate, won the election. And it was discovered that those who failed to participate in the election polls were overwhelmingly supporters of Roosevelt and were mainly responsible for the faulty prediction. So like they sent 10 million cards out there, and around 2.4 million were returned for response. So the response rate was around 25% only, or 24%. So this was an example of how data yet to be discovered caused incorrect values when the prediction was actually wrong.